Hello everyone. Today I'm going to give a brief discussion about air bearing. First of all, I would like to start with the what is air bearing. Basically, air bearing use a thin film of pressurized gas to support a load. This type of bearing is called fluid film bearing. Fluid film bearing have no solid to solid contact under typical running condition. Instead, a film of lubricating fluid, in our case which is pressurized gas, form a layer between the solid machine element and serves to transfer the force from one to another. The fluid is able to transfer force because as the fluid is pushed through the bearing gap, it generates a pressure profile around the bearing area. In our experiment, we are going to study how this pressure profile is generated in our with the change in angle. Now I will like to explain why use air bearing. Because of their advantage over roller element bearing, air bearings are a natural choice for applications such as coordinate measuring, machining, precision machine tool, positioning environment, etc. The main advantage of air bearings are first, zero friction. Because of the static friction, infinite resolution and very high repeatability are possible in air bearing. Second advantage is zero wear. Since there is no contact means virtually zero wear resulting in consistent machine performance and low particle generation. Third advantage is the state motion. Rolling element bearing are directly influenced by the surface finish and the irregularity on the guide. Being no contact air bearing average these errors. Next advantage is the silent and the smooth operations. Since recirculating roller or balls create noise and vibration as hard element become load and unload and change direction in turning tubes. This is especially noticeable in the resolution of scanners. But in our air bearing, there is no such motion is there. So the operation is silent and smooth operation. The third advantage is the higher damping. Being fluid flame bearing, air bearing have a squeeze flame damping effect, resulting in higher dynamic stiffness and better controllability. The sixth advantage is eliminated oil. Air bearing do not use oil lubrication, eliminating the problem associated with the oils. Seven advantage is high speed. High speed, higher acceleration can be achieved in the air bearing since there is no use of ball or roller, which eliminate the possibility of slip at higher acceleration. Now I will like to explain why air bearing is preferred over plain bearing and roller bearing. As we can see from the graph on the graph on y-axis there is a coefficient of friction log scale. On the x-axis there is plain bearing, roller bearing, and air bearing. From the For the plain bearing, the coefficient of friction log scale is zero point 0.1. For roller bearing, it's 0.01, and for air bearing is 0.0001. As we can see, compared to plain bearing and roller bearing, air bearing coefficient of friction log value is very less. Hence, the coefficient of friction will be also be very less. Hence air bearing is used where less friction, less load and low friction is required. Now I will like to explain the types of basic types of air bearing. The gas lubricating air bearing classified into two groups, basically classified into two groups, depending on the source of pressurization of the gas film providing the load carrying capacity. First is aerostatic bearing and second is aerodynamic bearing. In aerostatic bearing, the gas is externally pressurized using a compressor or a pressure tank and inject in the clearance of the bearing. But in the aerodynamic bearing, no such pressurizing instrument are used. In this, gas is pressurized by the relative velocity between the static and the moving surface of the bearing. Such bearings are the self-acting and do not require an external input or pressurized gas. Now I will like to explain the different stages in aerodynamic general bearing. Initially, the shaft is at rest and it sinks to bottom of the clearance space under the action of load W, which is shown in the first diagram. Here there is a contact between the journal and a bearing. Then, then the journal start to rotate and it's climb the bearing surface. As the speed increase is further, as the speed is further increased, it's force the fluid into the wedge shaped region, which is shown in the figure second. As we can see, the fluid is due to rotation, the fluid is forced to go in the wedge area. Since and this if we keep on increasing the speed, since more fluid is forced into the wedge shaped clearance area, and which will generate a system which is shown in the third figure, and the pressure distribution around the periphery of the journal is which is shown here. We have attached 20 duct tube around this periphery, and we have noticed that we have taken the reading of the pressure around this periphery, and we have make and the graph which is obtained us is on the y-axis it is the pressure, and on the x-axis is the degree of rotation from the central line. First, I will like to explain about experiment setup. In our experiment, we are analyzing the impact of RPM of shaft in the journal bearing on the pressure distribution while keeping the load on the bearing as a constant. Similarly, we will examine the effect of load on the bearing on pressure distribution while keeping the RPM of the shaft in the general bearing constant. In this, shaft is connected to a high-speed AC motor. The shaft is inside a bearing which is made of brass material. When the shaft rotates, it sucks atmospheric air, and due to the viscosity of air, pressure start to build up. Due to this pressure, due to the pressure, shafts start to float in the bearing. Bearing is connected to 20 duct tube, and this duct tube is connected to a sensor box, which is used to measure differential pressure. The bearing housing is suspended from a wire and a hook. This is used to increase the load or decrease the load on the bearing. These tubes in turns are connected to a controller. The pressure values are taken until steady state is not achieved. The pressure are processed and transmitted to the data acquisition cable to the computer, and the data is acquired on the PC.